Hello everyone, I am Elvis and I want to welcome you all to the World Challenge Club educational show. This week we're investigating the fascinating world of water and water power. If you haven't heard about the World Challenge Club, let me tell you. It is a place where you can do fun and exciting experiments while learning new things. There is also an online competition you can take part in to earn certificates and prizes. And you can even join with your classmates to make some teams. So come and join the fun. If you like making things or taking them apart to see how they work, then the World Challenge Club is for you. If you are already a club member, have you been trying out some of the previous challenges and putting your scores on the World Challenge Club leaderboard? Each show has a new challenge for you to complete. To do these challenges, you only need to use things that you can find in your home. For example, card, paper, scissors or bits of string. You can recycle spare things you may have around. Remember, each challenge you complete will give you a score. If you do well in the challenge by testing and improving your ideas and solutions, you will get better scores. The theme for this week's challenge is water and water power. And today's challenge is to make a cargo boat from a single sheet of aluminum cooking foil and find out how much cargo it can carry. The more it can carry before it sinks, the better your score. You will learn about things like density and displacement. If anything sounds complicated to you, it won't be by the end of the show. We will teach you any skills that you need to tackle each day's challenge. And we have people like Shad, our mathematics master from Charismath, to explain it all. Science and technology help us every day. From how we move things that we need around over land and sea, to generating the power that gives us electric light and television. We will be exploring some of these ideas today, tomorrow, and Friday. Do you want to play a part in making the world a better place? For that, you need to learn, understand, and apply science, technology, engineering, mathematics, or STEM. STEM skills help you to learn and understand the world better, so you may do better, think, act, and feel better. To turn dreams and ideas into reality, we have to change our hidden abilities into skills, our secret curiosities into knowledge. That's what makes people's lives easier, safer, and enjoyable. One group of people that use their STEM skills to invent amazing power systems for boats and ships are the designers, scientists, and engineers at Rolls-Royce.
I'm Dr. Helen Taylor and I work as Rolls-Royce as a metallurgist. Metallurgist is a materials engineer, so metallurgists choose metals for different jobs and they sometimes mix new ones, which is also known as alloying. So mixing or alloying means adding different things to a metal to change how it works, its properties. For aluminium, if I don't add anything, I get tinfoil like you're making boats out of, and you can just rip that. If I add magnesium, I can make it stronger, like for bikes and cars. If I add silicon and magnesium, it make it easier to melt so that you can make it into car engines and things like that. If I add copper, I can make it strong and light, so use it for aeroplanes. From university, I did mechanical engineering, which is sort of making things, mechanical engineers design things that move. My favourite subject was materials, so I went on to do it. Another word for the factors is properties. So, important thing would be strength of a material. If it's not strong enough, there's no point choosing it. But also cost, weight is quite often one that we use, and how easy it is to make. So, diamonds, they're really hard, really slippery. Why don't we use them for a slide? Well, because they're really difficult to make, anything big and flat. And they're really expensive. Lead is really easy to make, but it's really heavy and it's soft, so it's not very strong. You have to weigh up all of those different things to try and choose the right material. The material that you make your boats from is aluminium, and it's a metal. And when we talk about metals, we use things like density, and in boats, things being denser than water will sink, things being less dense. Now, density is when you take the whole area or volume of a material and you divide it by its weight. So it basically gives you its weight per like an area. It just makes it easier to compare a big bit of wood with like a little bit of metal. The wood is heavier because it's bigger, but if you took the same area, because the metal is denser, it would be heavier. For metals, they tend to be denser than water, or if you've got the same amount, heavier than the same amount of water. But because a boat is mainly filled with air, the whole density of the boat is actually lighter than water, so it can float.
Most of the surface of our planet is covered by water, and every day many hundreds of thousands of tons of cargo are moved across the oceans. If you were designing a new cargo boat, you would need to know that it would float and that it would safely carry the things that needed transporting. You would already know some materials that float and some that sink. Let's start our educational journey today by learning a little bit more about floating and sinking with a video from Twig Education that will teach you about density.
When a train at rush hour fills up with people, there is more matter inside the train. Therefore, the mass of the train becomes greater. Mass is a measure of how much matter, or stuff, an object contains. Even though the mass of the train increases when more people get on board, its volume does not. We say the density of the train increases. Density is the mass inside a certain volume. The metal steel has a density of 8 grams per cubic centimetre. This means if you take a cube of steel, which has sides of 1 centimetre, it would have a mass of 8 grams. For a cubic metre, this would be 8,000 kilograms. Different materials have different densities. Steel has a higher density than foam, which has a higher density than air. But the density of an object is often compared to the density of water. Fresh water has a density of 1 gram per cubic centimetre, or 1,000 kilograms per metre cubed. So steel has a density that is 8 times greater than water. If an object has a greater density than water, it will sink. But if its density is less, it will float. If an object floats, we say it is buoyant. So what would happen to some steel coins that are thrown into water? That's right, they will sink, because steel has a higher density than water.
You have learned that objects that have a density lower than water will float, and that objects that have a higher density than water will sink. Your challenge today will be to make a boat from a single sheet of kitchen foil that can carry the heaviest cargo. Kitchen foil is made from aluminium, and aluminium is a metal. So how can boats made from dense material like aluminium or steel float? Now, that is a fascinating and interesting question. After the break, you will go back in time over 2,000 years to find the answer to that. You would also learn more about the Foil Boat Challenge and how to test and improve your boat designs. Remember, your best design may even get a top place on the World Challenge Club leaderboard. If you're not yet a member of the World Challenge Club and you have a smartphone, you could sign up and be ready to start earning points to go towards prizes and certificates. I will see you soon after the break. Have you got something that you have made for one of our challenges that you would like to share and see on the show? First, check with your parents and then send us a picture on WhatsApp along with your first name, school and country to +44 744 096 3443 or by email to elvis@worldchallenge.club. We can't wait to see what you have made. Welcome back. Today's challenge at the club is to make a cargo carrying boat from a single sheet of aluminium foil. Your cargo could be small stones or beads. You would also need a way to measure how much cargo your boat can carry. So we will also show you how you can make a special weighing tool called a beam balance.
Humans have made boats and travelled across the seas for thousands of years. Ancient civilizations like the Greeks and Romans traded and expanded around the world with their great fleets of cargo ships that would carry food and drink and treasures to all corners of the known world. But travelling the oceans is not without risks. An overloaded ship would be unsafe in a storm. Oh dear. The sea is filled with wrecks of ancient ships that were lost in storms. Divers today can still find their cargoes on the seabed. Archimedes of Syracuse was a Greek mathematician, engineer and inventor who lived around 2,200 years ago in the country we now call Italy. While we do not know a lot about him, his name and his ideas are still used today. He discovered the laws of simple machines like levers and pulleys, and he founded the science of hydrostatics, how things float. While we may not know the exact way Archimedes came to understand hydrostatics, many people like to think he noticed the water rising as he sat in a bath. We still use his name to describe Archimedes' principle, the idea that a floating object displaces or moves aside its weight in water. When something floats and you try and push it down with your hand, you might feel it push back. That is buoyancy. A hollow shape, like the hull of a boat, can push a lot of water out of the way to generate a lot of buoyancy, enough even for a ship made of a material like metal to float. If you add cargo to your hollow boat, it will get heavier and push down against the buoyancy. When it can't push any more water away, it will sink, because it weighs more than the water it displaces. Modern cargo ships have special lines painted on their sides called plimsoll lines. They help those loading the ship with cargo know if it is safely loaded and not too heavy. To make and test your own boat and see how much cargo it will carry, you will need a washing bowl of water, you could use a sink or a bath, some sheets of aluminium kitchen foil. These sheets should be carefully cut into squares of 30 centimetres by 30 centimetres, some scissors, and some gravel or small stones or beads that you don't mind getting wet. We also need to find out how much cargo your foil boat can carry. If you have a set of kitchen scales already, you could use them, or you could make your own balance beam from a coat hanger. You will need 2 large tubs, old food tubs are ideal, and some string to complete your balance beam. If you have everything ready, it's time to make some boats. Carefully fold the aluminium foil to make the shape of the boat hull that you want to test. It could be long and thin, rounded, or wide and low. Try lots of different shapes. Put your foil boat gently in the water and carefully put gravel or your beads into the boat. Watch the water level on the sides of your boat carefully. When it starts to sink, stop. Assemble your balance beam using the 2 identical tubs at the end of the coat hanger. Tie another piece of string to the hook to suspend it. Adjust it so it hangs flat. Now collect the gravel that was needed to sink your ship and put it in one tub. Carefully balance it using marked bottles of water, 300 millilitres is about 300 grams, or rice poured from a cola or water bottle top, which is about 5 grams each. Add up all the amounts of weight and that is your score.
When an object floats in water, some of the water will be moved or pushed out of the way. How can we measure how much is pushed out of the way? Here is Shad, our master of mathematics from Charismath, who will explain it all to you. By using mathematics, you can devise a really useful measuring tool.
How do we turn a bottle or a jar into a volume measuring tool? This is part 1, and we're going to find out what to do about it. Take it, open it, Pour water into it, fill it up, and then tie a string around the jar. Take this bit, snip it off at the end, and then open it so that it looks like this perfect circle, which is the same as this circle over here. And if you know the area of the circle, you can move it down this height or this depth, and then multiply the height by the area. That's how you find the volume of water inside it. So to turn it into a scale, you first have to have water inside it, and you need to know how much water there is. Now, to find the volume is easy. First, work out what the area of this string is. The string that's going around, how do we find its area? You've done that before. Take 2r times 2r, twice the radius, that's the square outside the circle. Multiply it and you'll get 4r square. Now that you have that, take out the corner square because that's equal to the blue bits that's taken out, and remove that, you'll get 3r square. So you actually have a method. All you need to know is the radius multiplied by itself and then multiply that by 3 and you have your answer. Now, let's practice this with the circle. What's the diameter? Well, take a scale, measure the diameter, comes to 8 centimeters. So the radius is obviously half of that, which is 4. So 4 times 4, that's r squared. 3 times 16, that's 48. That's the area of the circle. Now, you found that out. The question is, the puzzle is, how do you know what's the length of the string going right around this bottle? What's the circumference? Now, to find that, we need to discover something about circles. Take the circle, string for example, snip it at the top, and then keep opening it like this. Snip it there and keep opening it until it turns into a straight line. Guess how long this line is? This is the same as the length of the circumference. And 3 of these diameters make up this line. So 3 diameters approximately equals to the circumference. Now that you know that, it's very easy to work out the diameter. Just divide by 3. And the circumference is the length of the string, which you can cut open to find its total length. And the radius, of course, is half the diameter. Now that you know this and this, well, you have everything ready to go to part 2, because then we'll find out how do we actually turn that jar into a measuring tool. Remember the string going around the jar? Well, we took the string, and when we viewed it from the top, that was the circumference of the water. It was 24 centimeters long, so what we did was to divide it by 3, and we get the diameter. And if you divide the diameter by 2, split it up into 2 equal parts, you get the radius. And there's your radius, r. And r square is 16 centimeters square. And we know that the area of a circle is 3r squares, which means 16 times 3, 48 centimeters square. Now that we have the area of this, which is the top of the water, we multiply it by the height, which is 10 centimeters, 10 times 48, and we get 480 centimeter cubes. That's a centimeter cube. 480 of these filling up this bottle all the way up to there. Some facts, it's too complicated pronouncing it centimeter cube, so we call it 1 liter, 1,000 centimeter cubed. And if you take 1 centimeter cube out of 1,000 centimeter cube, that's actually a tiny fraction, 1,000th of a liter. And we call that a milliliter, or ml for short. We can also think about the weight. 1,000 centimeter cubes of water weigh 1,000 grams, so 1 liter would weigh 1 kilogram. So now we know that the weight of this water is 480 grams because it's 480 ml. Now, turning it into a measuring device, we break 480 into 12 equal parts because that's easy to do. So cut 12 notches on a cardboard and mark it off. And if you divide 480 by 12, you'll get 40 centimeter cube intervals, which means these intervals are 40, 0, 40, 80, 120, and so on. We now have your volume measuring scale. Put that aside, keep it ready. Take a large bowl. Inside it, take a smaller bowl, fill it with water, put your paper boat, Fill it with grains until it sinks. And when it sinks, it displaces a certain amount of water, spills over on the side, and falls into the larger bowl. And it looks like this. So there's the water in the larger bowl spilt over. Tilt the bowl and pour it into the volume measuring scale that you created, and you see where it comes to. It's exactly 60 milliliters. And that's the amount of water, the volume of load that you poured onto the boat. And its weight is 60 grams. So you get both volume and weight using just one simple volume measuring scale. Now, make it yourself.
After the break, we will visit the lab to see how others tackle the challenge. I will see you shortly. Have you got something that you have made for one of our challenges that you would like to share and see on the show? First, check with your parents and then send us a picture on WhatsApp along with your first name, school and country to +44 744 096 3443 or by email to elvis@worldchallenge.club. We can't wait to see what you have made. Welcome back to the third segment of the World Challenge Club show. Here is Jazz in his lab to show us how he tackled today's foil boat challenge.
Hello and welcome to the lab. In the lab today, Jazz is folding sheets of kitchen foil to make cargo boats. Jazz will also show you how he made a beam balance to measure how much cargo his boat could carry. Remember, the sheets of kitchen foil that you use must be 30 centimetres by 30 centimetres. You can fold the foil by hand, but you can also fold it around an object to make it neat.
Green paper, clear the book, upside, and the same on the outside. I'm just bending over slightly so I know what height to make my wall. So one wall in, like so, make it strong. And then do the same with the other one. And then again, what you need to do now is start folding this in. And now you're going to make the front. Again, to fold the top up, let's make it a nice pointy shape. So give it a bit more height. Like so. Fold the top over. And there you have a nice little barge boat, which we are going to test in the water. So you can see it's sailing on a little ocean. When you do load your boat, make sure you spread the weight out evenly. Back's slightly heavy, so I'll move the weight forward. And you can see, oh dear, my boat is sinking. And away it goes.
Jazz is calculating how much weight he used by measuring how much is left from his original 500 grams. His boat carried 380 grams of cargo.
So let's see if you can beat me.
If you haven't got weighing scales, you can make a beam balance. It works like balancing a ruler on your finger. You can make your own beam balance from a coat hanger and recycled tubs. Find out how much weight it takes to balance your cargo. Jazz has made his own balance beam from recycled cardboard boxes and string. Do you have any final advice, Jazz?
Hardest part is fine-tuning it. Once you've got your skills fine-tuned, it'll be brilliant.
So that's it. Use a weighing scale if you've got one, or make your own balance beam. You can use water, which weighs 1 gram for each milliliter. Your total grams is your score.
We are nearly at the end of our show, and it's time to review everything before you go and have some fun testing and making your own foil boats. So what have you learned? You have seen that you can fold a material like aluminium foil to make a boat that can carry cargo. You have seen that something that floats displaces its own mass of water. You have seen how to make your own measuring tools for weights and liquid volumes. Before you go, let's remind ourselves of the rules. For your final foil boat design, you must use 1 square sheet of aluminium kitchen foil that is 30 centimeters by 30 centimeters. Load it with cargo like gravel or glass beads until it sinks. The amount of cargo it takes to sink your boat in grams is your score. You can use other sheets to test your ideas. Scientists and engineers capture data to help them make their decisions. You should also do the same. Keep notes about which shapes and designs of boats work best. Keep a record of your very best score and enter it onto the leaderboard at worldchallenge.club at the very end of the day. If you haven't signed up to the World Challenge Club yet, here is how you can. We can't wait to see those scores.
If you want to see anything that was in the show again, go to www.worldchallenge.club. The World Challenge Club will work on any computer, tablet or smartphone that can connect to the internet. There are extra resources there too, so you can learn even more. The World Challenge Club is also a giant competition for hundreds of thousands of students from around the world. To take part in the competition, you'll need to sign up and become a member. You only need to register once, but you must check with a parent or teacher first before you sign up. If you're under 14 years of age, they will need to include their email address too. So go to www.worldchallenge.club and look out for the green register button on a challenge page. Just click it and follow the instructions. You'll be asked to find your school and join a team. When you've signed up, you'll be able to upload your best score for each day's challenge. So after the show, check out the club and get uploading your scores. We can't wait to see how you do on today's challenge. Have you got something that you have made for one of our challenges that you would like to share and see on the show? First, check with your parents and then send us a picture or a video clip on WhatsApp along with your first name, school and country. Or you can email elvis@worldchallenge.club. We can't wait to see what you've made.
105 rounds.
You have seen how to use the club website, and hopefully you have everything you need to know to have a go at the Foil Boats Challenge and have some fun. Remember to keep a good record of the amount of cargo your boat can carry so that you can enter your best score on the club website. Before we let you go off to make some boats, there are a few people and organizations we must thank. Today's educational show was made possible with the kind support of Rolls-Royce. Rolls-Royce is a world-leading technology company and maker of power systems including engines for boats and ships. We have to thank Shad at Charismath, who made a special lesson just for you to tackle today's challenge. Remember what you were taught about making your own measuring jug. This lesson and many more from Charismath can be found at worldchallenge.club. The video about density was provided by Twig Education, who have online video learning resources for learners to access anywhere. We all look forward to seeing the results of your tests and experiments online at worldchallenge.club. So that's it. Have fun, and I'll see you soon for another challenge.